Okay, so we're going to do more practice first before we start the lesson. So I want you to take a look at this one. Conditional is if I am 18, then I can vote. I want you to write converse, inverse, and contrapositive for each one. So pause the video and I want you to try them and then check with the answers. So everybody pause the video and I'll show you the answers after you try them. Pause the video. Here are the answers. For conditional, P, if P then Q. If I am 18, then I can vote. Converse will be flip. So you're going to change order. If I can vote, then I am 18. Just change order, flip. Inverse is not. So if I'm not 18, then I can not vote. Contrapositive is flip, not. So we're going to use the converse, but just not this one. So flip, not is flip it. And then not, if I cannot vote, then I'm not 18. So hopefully you understand these things. All right, so let's do the lesson for today. We're doing biconditional statement. A single statement that combines a conditional and its converse. So when you combine conditional and converse, we call that biconditional. Bi means two. Written by joining two parts of each conditional using the phrase if and only if. If and only if can be abbreviated using IFF, if. To be true, both the conditional and converse must be true. So they both have to be true. For example, the statement is true when read forwards and backwards. So when you read forwards and backwards, it needs to be all true. A biconditional statement combines P, if P then Q, and Q then P, then if and only if P then Q. So they use these two arrows. This is a symbol for biconditional. A point is for example, a point is a midpoint if and only if it divides a segment into two congruent segments. So let's say this is a statement. A point is a midpoint if and only if it divides a segment into two congruent segments. The symbol will be P if and only if Q. This is how you read it. P if and only if Q. So this is the biconditional symbol. It's combining conditional and converse together. And they both need to be true. So this is how you read it. If P, if and only if Q. So this is called biconditional. So what is a converse of the following true conditional? If measurement angle A is equal to measurement angle B, then angle A is congruent to angle B. The converse is if angle A is congruent to angle B, then measurement angle A is equal to measurement angle B. So if you converse means you flip, that's the converse. So this is the conditional, this is a flip converse. If the converse is also true, rewrite the statement as biconditional. So biconditional will be measurement angle A is equal to measurement angle B if and only if angle A is congruent to angle B. So basically you are writing, combining these two right here. So you're writing this part, and instead of then you're going to write IFF. A statement that helps you identify or classify an object. Important component to a good definition. Use clearly understood terms. It's precise, avoid words such as large, sort of, almost. And it's reversible, meaning you can write a good definition as a true biconditional. So when we see definition, it's a statement that helps you identify and classify an object. So it has to have clearly understood terms, it has to be precise, like you cannot have as large, sort of, almost like vague words, and you can reverse, meaning you can write good definition as a true biconditional. So this is called definition. So identifying good definition, which of the following is a good definition? So I'm going to show you. Dogs are animals with 4 paws. That's a bad definition, an example of bad definition, because other animals have 4 paws as well. Squares have 4 sides. That is a bad definition because all quadrilaterals have 4 sides. Tuesday is a day before Wednesday. That is a good definition because that's definite. An acute angle has small measure. That's a bad definition. What does small mean? So the bad definitions they're kind of vague. They're not specific. You can have other example, like counter example, but this one is definitely 100% you can prove that's a good definition. So these 3 are examples of bad definition. This is an example of good definition. So let's do some practice. Is it a biconditional? I will work after school only if I have the time. You need to have if and only if. If you just see only if, that is not biconditional. You need to have if and only if, okay? An angle is called a right angle if and only if it measures 90 degrees. And then is 90 degrees called right angle? If you can reverse, this is true. If you reverse this, that's biconditional. So yes, this is a good, because 90 degree is right angle is a 90 degree. So either way, go back and forth. They're true, that's biconditional. And you see the phrase if and only if, then that's biconditional. 2 segments are congruent if and only if they have the same length. Yes, that's a good biconditional because if you have same length, they are congruent. Congruent segment, same length. So if you go backwards and forwards, and if they are both true, that's biconditional. Okay? So rewrite as conditional and converse. An angle is a right angle if and only if it measures 90 degrees. So this is biconditional. We're going to break it into conditional and converse, because when you add conditional and converse together, that's called biconditional. So IFF means if and only if. So conditional for this will be if an angle is a right angle, then it measures 90 degrees. Converse will be if an angle measures 90 degrees, then it is right angle. So basically, you just write this, and then you converse it, you flip it, and that will be the 2 parts. So please copy this down. It is Mrs. C's birthday if and only if it is May 30th. Conditional will be if it is Mrs. C's birthday, then it is May 30th. If it is May 30th, then it is Mrs. C's birthday. So you just write this and you just flip it. And then when you combine these 2, that will be the conditional here. When you combine these 2, they are biconditional.